on problems 1 through 6? Okay. Questions on problems 1 through 6? Okay, so if there's no questions on 1 through 6, we'll move on to 7 through 10. Questions on problems 1 through 6?
Can you do one of them?
Okay. Which one? So we always start from the left going to the right. So if we look at this here, the first thing we have is the 2/3. Now what transformation would the 2/3 be telling me that we have? It would be a vertical shrink. We know it's a shrink because the number in front of the parentheses is between 0 and 1. Now, since it's not negative, because if it was negative 2/3, it would still be a vertical shrink, but it would also have a reflection across the x-axis, because outside the parentheses would be a reflection across the x-axis. Yes, because this here is really just rehashing what we did in chapter 1.2 and 1.3 a little bit. Now, the next part that we do have is the -2 inside the parentheses. Now, because there's nothing being multiplied by the x, either a negative sign or a number, we don't have a horizontal stretch or shrink or a reflection across the y-axis. But the -2 tells me I'm moving 2 units to the right. Because inside the parentheses, it's the opposite of what we think. And that brings us all the way to the +3. Well, the +3 would be up 3. So the transformation for problem number 1 would be a vertical shrink of 2/3, followed by right 2 and up 3. And that would be it. Any other questions on number 1? Any other questions on 2, 3, 4, 5, or 6? Number 2. Now, if we look at this one here, going from left to right, well, the first thing we have is the negative sign outside the parentheses. Well, this here would be a reflection across the what? X-axis. Because a negative outside the parentheses being multiplied would be the x-axis. Well, there's nothing being multiplied by x, so we don't have a horizontal stretch or shrink or a reflection across the y-axis. But the +1 would tell me that it's doing what? Left 1. Because inside the parentheses is left or right. Adding and subtracting to the end is either up or down. And that's it. Any other questions on these here? We good with 1 through 6? Because 1 through 6, we're either going to have a reflection across the x or y-axis. A move vertical stretch or shrink, horizontal stretch or shrink. Most likely on the test, there will not be horizontal. Left, right, up, and down. Now, problem 7 through 10, we want to find the vertex and the axis of symmetry. Is there one of those in particular we want to look at? Number 9. Well, 9 is our standard form, ax squared plus bx plus c. Well, the vertex for this here is going to be the point negative b over 2a, comma, f of negative b over 2a. We're trying to find negative b over 2a. Negative b a. What is the value of b for this equation here? And a is, because again, this is still matching up with our ax squared plus bx plus c. Now our negative 4, well, the negative and negative would make a, and just be 4. 2 times 6 is, now 4 divided by 12 is 1/3. So the x value of the vertex is 1/3. Now it also tells me the axis of symmetry would be what? Or we'll count off if you just put 1/3. What is it? X equals 1/3. Is x equals the only type of axis of symmetry that we can have? No, we also have y equals, yes? On the homework, I did not count off for leaving off the x equals, but on the test, I will count that off. I will count that wrong because we do have two different forms. So that is also included for the directrix, because the directrix could be y equals or x equals. We have to specify that. Now, the only thing we're missing is the y value of the vertex, yes? Plug the x value in. So what we're going to do is we're going to take the 1/3 and plug it into the function. So we'd have 6 times 1/3 squared minus 4 times 1/3 plus 5. We're plugging it back into the function to find the value of y. Now at this point here, what we could do is we could just type this into the calculator. We can type it straight in. Because you can type 6 times 1/3 squared minus 4 times 1/3 plus 5, hit enter, and it would actually give you the answer. Now 1/3 squared would be 1/9. 4 times 1/3 is going to be 4/3 plus 5. Yeah, 6, and we can do that because we'll need to convert it. Now 6 times 1/9 will actually reduce down to 2/3. And exactly, Colton, because we can't, if we're doing this by hand, we can't leave the 5 as 5. I would switch it over to 15/3. I need the denominators to be the same, and 15 divided by 3 is 5. I mean, if this is getting you confused, just plug it in. I mean, there's nothing wrong with plugging that into the calculator. We don't have to do this by hand. If we did it by hand, we would set it up this way, and 2 minus 4 is -2 plus 15 gives you 13/3. Plugging into the calculator will just give you 13/3. We don't have to do this by hand. And any calculations like this here on the ACT, do it in the calculator. Don't do it by hand. It's going to take you longer to do it by hand than it is to type it in. It also reduces the number of easy mistakes that you will make. Now, plugging something like this in, especially on the ACT, I would use the TI-30XS, the yellow calculators, because y'all can type a fraction faster on that than you can on the graphing calculator. Yeah, just do it that way. And any of them, whenever you come up to it, if the yellow calculator can do it and the graphing calculator can do it, use whichever one you find easiest to type in. But any questions on 9 or 10? Are we good with 9 and 10? We can look at number 8. What's the vertex for number 8? But that's just coming from the h and k. Since it's x plus 1 inside, the value of h is -1. K, we don't mess with the sign. Now the axis of symmetry would be x equals, and that's it. Any questions on 7 through 10? We ready to move on? Questions on 11 through 16? Any questions on 11, 12, 13, 14, 15, or 16? Do we have this equation set up in the way we need it to find the directrix focus, or the focus, directrix, and axis of symmetry? Well, no, because if we want these, we need to either set it up as y equals 1 over 4p times x minus h squared plus k, or x equals 1 over 4p times y minus k squared plus h. Now, because here, if we have 4x squared minus 8y, well, the y is the one without the power, so it needs to be by itself. So we do need to rewrite this equation. So what do we need to do first to get y by itself? We can, but there's actually a simpler way. Because I can add 8y, because we could subtract the negative 4x squared, and if you did that, that's perfectly fine, because then we would divide by negative 8, and we'll get to the same place. Because if we add 8y to both sides, well, we would have 8y equals 4x squared. And then what would we do next? Now, I put the y on the left-hand side just because it's nicer to just have that variable on the left instead of on the right. Now, 4 divided by 8 would reduce to 1/2 x squared. Now, to find the vertex, or the focus, directrix, and axis symmetry, didn't ask for the vertex. We need the values of h, k, and p. What's the value of h and k? Yeah, 0, 0. Because in both of these here, where does the h and k appear in the general equation? H is inside the parentheses being added or subtracted from our variable that's being inside the parentheses that are being squared. And h or k is being added to the outside. Do we have a value in either spot? No, it is going to be 0 and 0. Now, have we gone over a method for actually finding h and k when it's not given to us in this general setup? Have we? No, because if we're actually have an h and k value, and we're trying to find the focus, directrix, and axis of symmetry, it's already set up in the form y equals the entire equation with the parentheses already given, yes? So if we're actually trying to get y by itself or x by itself, it's safe to assume, at least on this test, the vertex is going to be what? 0, 0. H and k are going to be 0. Now, and all that leaves us with is p. Well, what is the value of p? Do we know yet? No. But we do know that the 1/2 is in the same place as what? 1 over 4p. So what we can do to find the value of p is we'll set up 1/2 is equal to 1 over 4p. Now we can multiply both sides by 4p. Now the 4p and 4p will cancel, which will give us 1. Now 4p times 1/2, or 4 times 1/2 is 2p. And what can we do next? Divide by 2. Divide both sides by 2. Now that tells me p is equal to 2. Now if you're wondering, well, it started out as 1/2 and p is 1/2. Well, that's just coincidental. On all the homework assignment problems and the ones we've done previously, it never worked. It only works out that way in this one case. So just because the number in front of it was 1/2, p is 1/2, it works out this way for this problem. It won't always work out that way, and y'all have seen that already. Now the vertex it didn't ask for it would be 0, 0. Now the focus, which it did ask for this problem, well, we have what? The equation is y equals, yes? So I can go over to the general equation. It's y equals. Vertex is hk. Focus is h comma k plus p. Well, what is h? H Well, the k plus p, I'll erase this here. Well, k plus p, well, that would be 0 plus, which is 1/2. Directrix, well, that's going to be y equals, that would be k minus p. Well, our k minus p would be 0 minus 1/2, which is, and last but not least, the axis of symmetry would be x is equal to 0. And that's it. So on this here, when we're finding the vertex, well, it didn't ask for it, but vertex, focus, directrix, and axis of symmetry, what are we trying to find? 3 things, h, k, and p. Because if I can get those 3, I plug in, I get the vertex, focus, directrix, and axis of symmetry. Questions on this here? Really yes? It is RK minus P for directrix. Now, even if we weren't able, if you get a mind block tomorrow and can't find the value P, but we can find the vertex, yes? You all feel comfortable with finding vertex H and K? So even if I can't find the value P, how much of this can I actually get? Well, I can get the vertex completely, yes? I can get one value of the focus, and I can get the, so 1, 2, 3, 4 out of, well, 5 out of, say, the 7 points. Or so, yeah, 5 out of the 7 points. And I lose the 2 for not being able to find the 2 values that require P. And that's it. Questions on this here? Is there another one that we want to look at? Number 16. So, number 16, y equals negative 1/4 x squared. Is it set up like we need it? Yeah, it's already set up in the way we need it. So the values of h and k are both what? 0. So really the only thing we need to find is P. Now the vertex is going to be the point what? 0, focus. Now because it is y equals, I can come back over here. Well, the focus is h comma k plus p, yes? Well, we already have the h value. It is 0. Directrix is going to be y equals, and the axis of symmetry is x equals. So I just went on and plugged h and k in. Because once we find the value p, then we can apply it. Any questions on this here? Now, how can I find p? Well, it's going to be using the 1/4p, and we set it equal to what? Negative 1/4. And what would we do? Multiply both sides by 4p, because the 4p and 4p here will cancel, leaving us with 1 is equal to negative p. Because the 4/4 here would cancel out, because negative 1/4 times 4 is negative 1 times p. So we have negative p. Or p is equal to negative 1. Any questions on how we found the value of p? Are we good on this here? So now we just need to plug it in. Now, we know for the focus, this would be k plus p. Well, k is 0. P is negative 1. So 0 plus negative 1 is -1. That directrix would be k minus p, so 0 minus -1. And 0 minus -1 is 1, because a negative and negative would make a positive. And that's it. Questions on this here? We ready for the next one? So any other questions on this section here? Questions on 15 through 19. 15 through 19. One of those that we want to look at. Fifteen, yes. And I'll tell you this here, really, 11 through 27 has one key component to the entire section. We're trying to find three things on any of them, and what are they? H, K, and P. Because if I find those three, no matter what the setup is, because I'm either going from the equation to vertex, focus, directrix, and x as a symmetry, or I'm going from vertex, focus, directrix, and x as a symmetry back to the equation. And going either direction, if I have H, K, and P, we plug it in and we're done. Now here, we have 1/4, 0 as the focus, and the directrix is x equals -1/4. Well, the only one of the two equations that has a directrix of x equals is our x equals 1/4p times y minus k squared plus h. Because it says the directrix is what? X equals h minus p. The directrix here is x equals. Both have x equals, so that's the equation that we're using. Y equals, nope, I say that. Say x equals and I write y. X equals 1/4p parentheses y minus k squared plus h. Now again, I'm just looking back at the general example, which tells me the focus is h plus p comma k, and the directrix is h minus p equals -1/4. Now I can see from the focus k is 0, yes? What's the value of h? Well, h plus p is 1/4, h minus p is -1/4. What's the only number I can add or subtract from and still end up with the same number, maybe a different sign? 0 plus 1/4 is 1/4. 0 minus 1/4 is -1/4. So really, if it worked out that the focus and directrix have the same value but opposite sign, the h or k has to be 0. That's the only way we can do it. Because h minus p gives us -1/4. H plus p gives us 1/4. H has to be 0. Because we could actually go through and solve, but there's no other way for that to work. Because let's just say 0.5. Well, 1 minus 0.5 is 0.5, yes? 1 plus 0.5 is 1.5. It's going to give us a different number. So h and k have to be 0. Any questions on this here? Now we need to find the value of p. Now we do know h, so it doesn't matter which one we use, because I could say h plus p is equal to 1/4. Well, what's the value of h? 0 plus p equals, so p is Any questions on how we found the values of h, k, and p before we plug back in? Well, we can plug this back in. So we'd have 1/4 times 1/4 times y minus 0 squared plus 0. What is 4 times 1/4? 1. 1 divided by 1 is 1. So really what we're saying is this entire first number is 1. What's y minus 0? And then we square it, yes? So it'd just be... So that first one is just x equals y squared. So what did we do? We found the values of h, k, and p, plugged them in. What did we do in the last one? Well, we found the values of h, k, and p, and... Any other questions on these here? On this one here? Questions on 16, 17? And 18 are almost going to be the exact same. It's just going to be the difference of directrix and focus. 18 or 17, and we can look at 18. What is h and k for 17? Because the vertex is the point what? H comma k. So it told us h and k are 0. Oh. Now the directrix is, for this here, x equals what? It would be our h minus p would be negative 2/3, because the equation for the directrix that's given to us from the general equation tells us the directrix x equals h minus p. Here we have the directrix is x equals negative 2/3. X equals x equals. So our h minus p should equal negative 2/3. Well, what's the value of h? 0, so it's gone, yes? Because we could write 0 in, but 0 minus p is just the same as saying negative p equals negative 2/3, yes? We good with saying that? So what's p? Do I have everything I need to find the equation? Yes, so we can plug it in. So our equation for this here is going to be our x equals 1 over 4 times negative 2/3, parentheses, y minus 0 squared plus 0. Well, 4 times negative 2/3 give me a whole number. Yes, thank you. Thank you. Should be positive, thank you. Yep, switch the signs and I completely lost track of it. Now, will 4 times 2/3 give me a whole number? Well, no, it's going to give me a fraction, yes? Type it into the calculator. 1 over 4 times 2/3. That's how I would do it. Now, we can do it by hand and say 4 times 2/3, which would give me 8/3. And then simplifying it down would be 3/8. Because the 1 over 8/3 would have to do 1 divided by 8/3, which is 1 times 3/8, which is 3/8. Now the calculator will do it just fine. And again, like on the ACT, let it do it for you. Y minus 0 squared is just y squared plus 0 is just going to still be y squared. Now, if we have a number inside being added or subtracted from the x or y that's not 0, we leave it. Because if it was y minus 1 inside those parentheses being squared, we just leave it as y minus 1 or y plus 1. The only reason we're dropping the parentheses is because y minus 0 is the same as y and squared, so we don't need them. Any other questions on this here? We good with this here? Now, just like the last one, they gave us the vertex, so h and k are both 0. We just need to find the value of p. Now, this is telling us that h or k plus p is negative 4/5. Well, what is k for this problem? 0. So that's really just telling us p is negative 4/5. Now, since we had 0, negative 4/5, going from vertex to focus, 0, 0, well, the y value changes from the vertex to the focus. So it's telling me that the equation that I have is y equals 1 over 4p, parentheses, x minus h squared plus k. So we have y equals 1 over 4 times negative 4/5 times x minus 0 squared plus 0. Now again, just like with the one we had previously, 4 times negative 4/5 will not give us a whole number. It'll give us a fraction. So we can go on and just plug it in, and it should be negative 5/16 x squared. Because the x minus 0 squared is just going to be x squared. Questions on this here? Now, if you'd have written negative 5/16 parentheses x minus 0 squared plus 0, I'm not going to count it wrong. It is the same thing. But it's good to reduce and simplify it down if we can. Any questions on 18? We go with problem number 18? Questions on 20 through 23? Questions on 20, 21, or 22 or 23? Yes. 21. Okay. So we want to find the vertex, focus, directrix, and axis of symmetry. Well, to find those, we need what? H, K, and P. So looking at this here, well, we can get H and K. Well, what's the value of H? Negative 1. And where'd you grab that from? Outside, because what is this? X equals, yes? X equals 1 over 4p parentheses y minus k squared plus h. Because it's x equals, the h and k are flipped. Now, what is the value of k? Negative 1. Because plus 1 on the inside would come out as negative 1. The minus 1 on the outside is still negative 1. So here, even though you flipped them, you still have the same value. But that's one thing you need to be careful with going in either direction, finding the equation or finding the vertex, focus, directrix, and axis of symmetry with x equals. Because with the general equation, the h and k are switched from the normal form. So be paying attention to that. Now the only thing we're missing is p, yes? Well, where is p located in the general equation that matches up with this one here? 1 over 4p, and the 1 over 4p matches up with our negative 7, yes? So what we can do to find p is say negative 7 is equal to 1 over 4p. And the first thing we would do is multiply both sides by 4p. Now the 4p and 4p will simplify to 1. Now 4 times negative 7 is negative 28p. And from here we can do what? Divide both sides by negative 28, telling us that p is equal to negative 1/28. Any questions on how we found the value of p? What's our vertex? Negative 1, because it's just h comma k. Now the focus, and again, I would look straight back at the equations, tells me that it's h plus p comma k. Well, I do know what the value of k is. It is negative 1. I'm going to erase this here, because to find the x value, well, that is our h plus p. Well, what is h? plus negative 1/28. Well, that would be negative 1 and 1/28. Or if we wrote it as a mixed number, an improper fraction, it would be negative 29/28. And again, you can type that into the calculator. So that gives us vertex, focus, directrix would be what? What are we starting off with? X equals h minus p. Well, h minus p would be negative 1 minus negative 1/28. Well, the negative and negative would give us a positive. So we have negative 1 plus 1/28, which is negative 27/28. And last but not least, our axis of symmetry would be y equals negative 1. And that's it. So for these here, I find the values of h, k, and p, and we plug them in. Questions on this here? Do we want to look at another one? Okay. We would do the same thing for the other ones that we just did for this here. I did get another one in during second hour, sorry, this is, yeah, no, I got one more in third hour, so if you want to look at it, you can, okay? Now what I want to look at is 24 through 27. X focus, directrix. Any one of those in particular that y'all want to look at. All right, we can look at this one here since it's up. Now again, we want to find the values of h, k, and p. The values of h, k, and p. And one of the big things, especially given the vertex and focus, is I'm trying to see which value changed from the vertex to the focus. Is it the x value or the y? Now we're looking at this here, it would be the x because it's going from negative 4 to negative 6. So I see that the general equation for this here would be our x equals 1 over 4p times y minus k squared plus h, because that's the one it matched up to. So we have h plus p comma k. Now to find the value of p, what it's telling me is that h plus p is equal to negative 6, because that's the x value of the focus. Now we do have the value of h. H is negative 4, so we're saying negative 4 plus p is equal to get p by itself, I would. So p is equal to any questions on we found h, k, and p? Plug it back in. So we'd have x is equal to 1 over 4 times negative 2 times y minus what? 4 squared plus negative 4 or minus 4. Because again, we got to be careful on where we plug in h and k. Now at this point here, we can simplify down. 4 times negative 2 would end up giving us negative 1/8. Y minus 4 squared minus 4. And that's it. Any other questions on 24 through 27? Questions on 24, 25, 26, or 27? 27. Well, the vertex is telling me that I have my h and k. Vertex is h comma k. Now the directrix x equals, well, there's only one of the two general equations that would be x equals. So for this here, we're saying that this is really taking the place of h minus p. Now we know that h is 5, k is 2, but we don't know what p is. Now I do know that h minus p is -7. Now we do know what the value of h is. H is 5. So we can plug it in, telling us that 5 minus p is -7. The next thing we can do is subtract 5 from both sides, telling us that p is equal to -12, or p is equal to 12. So any questions on how we found h, k, and p for this here? Now again, we'd plug it back in, because we'd have x equals 1 over 4 times 12, parentheses y minus k, which would be 2 squared plus 5. Now our 4 times 12 would be 1 over 48 times y minus 2 squared plus 5. And really, with any of these set here, we're really finding what's the general equation and matching it up with the information that is given. So any questions on those there? Okay. I know the bell's about to ring, but let's look at 28 through 31. Are there questions on 28, 29, 30, or 31? Okay. Now 28 gives us a vertex and a point that passes through or is on the equation. So the equation that we're going to be utilizing is y equals a times x minus h squared plus k, because this is the general form of the equation we use for this type of problem. Now the first thing we're going to plug in is the value of h and k. So here we'd have y equals a times x minus 2, because that's the value of h squared, plus 4, because we plug h and k in to get those spots. Now the only thing we're missing for the equation is the value of a. That's where we're going to use the 0.06, because what it's saying, y is equal to 6 when x is 0. So if we plug 0 in for x, the y value should be 6. Now at this point here, we can solve for the value of a. Well, 0 minus 2, -2 squared is 4. Now at this point here, we can subtract 4 from both sides. The 4 minus 4 will cancel out, and 6 minus 4 is 2. So let's tell us 2 is equal to 4a. And from here, we can divide both sides by 4, telling us a is equal to 1/2. So we have y is equal to 1/2 parentheses x, what is it, minus 2 squared plus 4. And that'd be the general equation. So for these here, really what we're doing is we're plugging the h and k in to start the equation, plug in the point to solve for the value of a, and then simplifying from there. So y'all can go on and head out. Now, does anybody want to see the other type with the X-Intercepts? Mm-hmm. 0 minus 2 is -2. -2 squared is 4. Because -2 times -2, the negative and negative make a. Mm-hmm. Yep. So then we subtracted 4 to get a by itself, 4a.
So why do we put the 4 in front of the a?
Because -2 squared is 4. 4 times a is. Mm-hmm. Zero minus 2 is. Yes, because with 4a and plus 4, they're not like terms. So I have to subtract it. and then divide by 4 to give us 1/2. Okay. Also, the other type with the X-Intercepts is in third hours video. So if you want to go there and watch it, you can. Okay? Because I did cover this one in third hour.